Hello students, in this video you will find quantization of angular momentum and the Broglie equation. Quantization of angular momentum. Angular momentum. And the Broglie relation. The Broglie equation. I am going to tell you point wise. First point, according to Bohr's concept, Bohr's postulate, electron revolve around the nucleus in a definite circular path. In a definite circular path like this. In a definite circular path. And here is the nucleus. Electrons are revolving in a definite circular path like that. And this is called orbit. Orbit. These orbits are Bohr's orbit or shell are represented by K, L, M, N and so on. First shell is represented by K near closest to the nucleus. Now second one L, third M, like that from first shell closest to the nucleus outward. These cells are represented by K, L, M, N. First one is by K, second L. And the cell closest to the nucleus has minimum energy. On moving outward, energy gradually increases. Energy increases on moving from the first cell to outward, energy is increasing. Now, second point, if electron has wave character, then electron revolve around the nucleus in this circular orbit in the form of wave. Once again, if electron has wave character, then it revolves around the nucleus in the form of wave in Bohr's circular orbit of radius r. Here, the radius of this orbit is r. Third point, there are two types of electron waves. A wave in which when two ends of the wave meet to produce a regular series of crest and trough, then the wave is called in phase, constructive. Wave, you know, wave is this. Here crest and trough. This is called wave. And suppose this is a wave, then this is called crest and this is called trough. And this is called wavelength, lambda. Then if two ends of the wave meet to produce regular series of crest and trough, the wave is in phase. Second type is if two ends of the wave do not meet to produce regular series of crest and trough, then that wave is out of phase. Such wave interfere destructively, cancel each other and destroy itself. Now next point. A wave which is in phase can be accommodated in the Bohr's circular orbit. What does it mean? It means if the circumference of the Bohr circular orbit, this circumference 2 pi r, is equal to the integral multiple of the wavelength of electron wave. Integral multiple of the wavelength of electron wave. Then only electron wave can be accommodated in the Bohr's orbit or that wave is in phase. Now let us see that. Suppose here is circular orbit In that circular orbit, this is a circular orbit. Now electron is moving there. Electron is moving there in the circular orbit in the form of wave, this wave. Here, electron is moving in the orbit in the form of wave, like this. It is moving here in the form of wave, like this. And in this case also, see, these two ends are not meeting constructively, hence this wave is out of phase. Out of phase. Because these ends do not meet to produce a regular series of crest and trough. Next point is, if this in this case here wave, electron wave in the Bohr's orbit, electron wave in the Bohr's orbit. Now for this also, electron is, wave is coming like this. Like this, see, wave is, electron wave is moving like this. And producing a regular series of crest and trough. Then this wave is in phase, and this is here nucleus, this is here radius. Here two ends of the wave don't meet to produce the regular series of crest and trough. And in this, here ends are meeting to produce the regular series of crest and trough. It means that wave is accommodated in the Bohr's circular orbit. Now, if for this case, circumference of the circular orbit, circumference of circular orbit 2 pi r is equal to integral multiple of the wavelength of the wave, then only it is possible. And second point, according to the Broglie equation, but here we can say, or lambda equal to 2 pi r by n. Second point, from the Broglie equation, lambda equal to h by mv, where h equal to Planck constant. Its value 6.625 into 10 to the raised power minus 27 erg second. And m equal to mass of electron, v equal to velocity, m into v equal to momentum, like that. Now from first and second equation, this first and second one, this one, lambda equal to 2 pi r by n, this one equal to h by mv, or we can write this here 2 pi r by n equal to h by mv, 2 pi r by n equal to h by mv. Now we can write here mv into r, mv into r, this part mv into r, mv into r, angular momentum equal to nh by 2 pi, nh by 2 pi. Hence quantization of angular momentum by Bohr's postulate is derived by using the Broglie equation. Then this is the relation of quantization of angular momentum and the Broglie equation. We can derive that quantization of angular momentum by using the Broglie equation. Now that's all for today. Again, next video you will find next very important thing. Thank you.